I'm building a working Lego monitor out of this broken laptop to see if faulty old tech can still be useful with the help of Lego, as I could really use an extra monitor. But I have a feeling this might be a lot harder than it seems. However, before we can build anything, we need to separate this display from the laptop. I've never worked on laptops or other electronics before, so it was quite nerve-wracking to tear this thing open, especially since there were no clear service manuals on this particular model. I actually used this laptop for over 6 years, but a year back, while I was gaming with friends, it suddenly turned off. Sure, it was weird, though I thought it had simply crashed like it usually did once in a while. However, it would never turn on again. It had short-circuited. After learning that, we retrieved the hard drives and they were thankfully all fine. And with that in mind, I'm hoping to get equally lucky with this display, since it would be the perfect use of an otherwise dust-collecting defective laptop. To find out if this LCD panel still works, we need something called a controller board, which converts the signal of this display to a standard HDMI port. So I tried to find one for my specific model number, but that was more difficult than expected, because most of them would need a month to ship. Therefore, I opted for a general unit that's not tied to a single model number. Let's hope this works. I plugged the cable into my display, found a power supply, and it actually turned on right away. Let's go! Though there were some weird white dots moving all over the place, and I couldn't tell if this was an issue within the display from when the laptop short-circuited, or if it had to do with the controller board. But after doing a little research, it does seem like it's the universal controller that's causing this. However, the good news is that switching to a specific one would resolve this issue. Though I'm really not sure what I'm gonna do with this yet. Let's first see if we can build a proper monitor enclosure. A tricky thing was figuring out how to mount the display to this frame, because the mounting holes are smaller than the diameter of a Lego bar, which was my initial idea. But then I found these flowers with very narrow stems. They looked quite promising. However, the stems unfortunately were slightly too short and therefore couldn't provide a solid connection. And now that I think about it, I've made this extra bit of bezel that doesn't do anything useful. Maybe the bezels can hold the display, and we don't need those mounting holes after all. So let's build a proper new design. I in fact made several different designs. However, this one was too bulky, this one didn't cover the edges enough, and this one wasn't secure enough. So I was about to lose my head. But then I found these L-shaped panel pieces. This was exactly what I was looking for, though I didn't have enough of them in my inventory to fill both sides. So I had to tear apart some of my old builds to accumulate enough of them. But that is simply standard procedure when building with Lego. It was only now that I noticed that the bezels of the LCD itself are not evenly sized all around. In fact, all 4 of them are different. This was going to make things even more challenging. But at least for the left side, I figured I could add a layer of tiles to compensate for the different measurements. However, these panels wouldn't accommodate any usual type of tile. So I looked through my bins and found these triangle tiles, which have this tiny cutout in the corner, which makes them fit perfectly here. This is exactly why I'm doing this and all my other projects using Lego. Because sure, something like 3D printing might be easier here. But there's just something about puzzling with the limitations that these bricks present that I so thoroughly enjoy. And I've already built things like a CarPlay phone dock and pool table before, so surely a monitor will work as well. That's the monitor housing done. And it's honestly getting hard to see that this is still Lego. Now for the top border I built a simple beam and used some more of these panels to create cutouts for these bits that poke out. In order to accommodate the protruding circuit boards, the bottom bezel had to be slightly larger than the others, though that's fairly common on monitors. I also added these green brackets for the metal bits to rest on, and I embedded some Technic Lego beams to eventually connect this to the Lego monitor stand, which we'll get to shortly. But then I realized I had completely forgotten about mounting the controller board. So I teared everything open again, added some bricks with studs on their sides to hold these standoffs, onto which I could place the controller, and I secured it in place with these yellow Technic bushings. Then, to finish it all off, I made a cover to protect it against dust and other stuff. Mounting the button board was a little trickier, because its holes were too small to fit Lego bars, just like with the LCD. So I again tried multiple solutions and finally settled on these antenna pieces, which I heavily reinforced until the board no longer moved when a button was pressed. Lastly, I plugged the cable into the monitor and replaced a section of the bottom bezel with this panel to give the cable as much room as possible. This looks excellent, but I can't hold it myself forever. So let's build a Lego monitor stand. This is where it's going to get challenging, since the monitor has to rotate, be height adjustable, and most importantly, have a very secure connection. This V-shape will be the base of the stand, and I clamped these little tires on the bottom to prevent it from sliding. Before I moved any further, I removed every electrical component from this frame, since it's better to be safe than sorry. Now, first the rotary motion. I reckoned that one of those heavy-duty turntables would work pretty well here, but I don't have any. Therefore, I made something similar myself. I placed a big rotating gear in the middle, and these surrounding gears on friction pins help smoothen the movement, because the more you add, the more force will be needed to rotate the monitor. And as a bonus, they also help to keep the larger gear in place. It turned out to be quite a strong connection. However, because it is only attached with one axle, it was a little wobbly. Though I think I already have an idea how to fix this. But for that we must first continue building the stand. I'm actually doing this project only using the bricks I already have, to show that you can do something similar and make a nearly free monitor yourself. Because a controller board only costs around 20 euros or dollars. And you don't necessarily have to make an enclosure out of Lego. This is just my way of engineering, but I'm sure there are lots of other ways to do this. I've worked out a couple of ideas for the height adjusting mechanism. First one was using these slopes, so you can always move the monitor up and it then locks immediately. But this was a little too complex, since these slopes would have to move for this to work. Therefore, I also considered using a beam with gear racks, but the gears couldn't handle the stress. So I had to look further. I do know there are lots of perfectly fine cheap monitors out there, but this project is not necessarily about the cost, because I do realize that Lego is expensive too. But this is more about saving useful parts from otherwise broken devices to build something awesome. And the story that goes with that is incredible in my eyes. Because who else in the world has a custom monitor built out of Lego? I presume not many, but I'm absolutely loving the build this far. I've now built the walls using these bricks with pinholes, and made a very strong inner column by stacking plates sideways. But it was so extremely tight that I had to remove the layer of tiles for it to move smoothly. Once you've found your desired height, these two pins can then lock the monitor in place. To fix the aesthetics and form a stable structure, I added these large plates, because they interlock with these bricks with studs on their sides. To fix the bending issue, I came up with this idea to add these little support walls that fill the area between the stand and the monitor. And after some quick final structural improvements, I believe it is about time to finally reinstall the electrical components once and for all. And there it is, the nearly free, fully functional and adjustable monitor, built using Lego. And that's exactly what makes this thing so brilliant. Because it being Lego means you can customize this exactly how you'd like. You can have this simple clean aesthetic, or you can intentionally leave some studs exposed in order to add some decorations, or add something like a watch charger. The possibilities are endless, and that's why I absolutely love this thing. Therefore, I would highly advise anyone with an old unused laptop to do a similar thing. But please learn from my mistake and find yourself a controller board that specifically lists your panel name, even though I barely notice those white dots anymore. So it turns out modern technology goes together brilliantly with Lego. But would the same be true for old technology? To find out, I tried building a functional Lego typewriter in the previous video. Thanks so much for watching, and I'll catch you in the next one.